Christine, are you there, darling? Hello?
Hi.
Okay, you're there. All right, what we're going to do is we're going to look at the first nitrogenous bases. So let's have a look at them, and it's UCA. So we're going to write them down here, U, C, and A. Okay. The first three nitrogenous bases on the DNA strand that led to the formation of Z. Okay, so now remember, they want the first three on the DNA, not on Z. So at Z here, we're looking
At DNA.
right, we're looking there at the messenger RNA. So your DNA is going to be opposite. Do you remember that? So now we go here, and the DNA is going to be, so the answer to this question will be on the DNA, and on the DNA it is going to be, what is opposite to U?
It's going to be like T.
Remember A to T, yeah, and G to
A,
C.
Then C to G.
So that is going to be A
C,
and G and
A, and T.
and T. Cool.
Yes.
You understand it? Perfect. Do you see how easy it is, Christine? Hey?
Yes,
Yeah.
it's Christine.
Yeah, exactly. It's easy. All right. Name the part stage of the protein synthesis that's illustrated at O. Now, if we go back here at O, what's happening? You have transcription and translation.
Nation.
Exactly. So when the messenger RNA copies or codes onto the DNA, that is transcription. We are transcribing. To scribe means to write. Okay? Means, so when you transcribe, it means you are copying over. So that's when the messenger RNA codes on for the DNA. Then it's transcription. All right? And then here, when the amino acids are produced because of the code on, or the anticodon of the transfer RNA, then we say that it is transcription and that's it. So we have translation happening here. Okay, so that was my answer to this question. Name the parts or stage. It is translation. So in other words, what's happening is it's saying, okay, we've got the recipe now. Now we're going to make something that is exactly the same as what was on the DNA. All right, now we look at this, and it says the table below shows a base triplets of DNA and the amino acids each triplet codes for. So now also you've got to please, in the back of your head, remember that your amino acids will group together to form macromolecules, which are called proteins. And all your cells, your hormones, your antibodies, and your enzymes are made of protein, except your sex hormones. So your estrogen and progesterone, because you're a girl like us, okay, in a male, the testosterone, those hormones are just fat. But every other hormone in your body is made of protein, okay, and the cells, your cell membranes have got protein, all the organelles have got protein, the nucleus is protein, everything is protein in a cell. All your enzymes, all protein, and your antibodies. So without enzymes, there are no catabolic or anabolic reactions in your body. Without proteins, there are no hormones. Without proteins, you have no antibodies, you will die. Okay, so if we look here, it says our base triplet of the codon, of the DNA, and then you have the amino acid coded for. So this is what will make your amino acid. Now, if I say here, what is going to be my messenger RNA for these? Now let's just take one. Let's say A, G, and T. So remember, A equals T and G equals C. And the reason I do this is to show everyone how to do it so that you never, ever, ever get confused. You will never, ever mess it up if you write this on the side of the question. Okay, so AGT, which means what is the opposite of A is going to be T.
Thymine.
Thymine, correct. But in messenger RNA, there is no thymine. There is
Uracil.
That's good. Okay, G will be C and T will be A. So there is my messenger RNA for serine. So this is going to go, and this will then go to the transfer RNA, and the transfer RNA is going to pull out this amino acid for what sits here on this DNA. All right. Do you understand that?
Okay. Yes, I understood.
Good. Right. Now, with reference to the diagram in question 2.2 of the table above, name the amino acid labeled P. So the amino acid labeled P, we've got to go back, and let's see here. P is UGU, so we go back here. So U, G, and U. That is the amino acids code. All right, so one of these is going to be UGU. So the opposite of UGU is going to be what? It's going to be A,
T,
C, A.
gonna be C.
In other words, it is this one, which is cysteine.
Okay.
Do you see that?
Yes.
Okay.
Yes.
Because remember, this is always going to be opposite. So we've got that one. State the base sequence of the molecule labeled Q. So let's go back and have a look at Q. The base sequence of the molecule Q is GGC. So let's just write that down. This is going to be GGC. And it says this. State the base sequence of the molecule. So the base sequence going back to the DNA is going to be the opposite. And what is the opposite? Let's use another color here.
It's gonna be C,
Uh-huh.
then C,
Uh-huh.
then G.
Perfect. You got it. Look at that. You've already got 4 marks here. I mean, so far you've got full marks for this question. All right. What name is given to the triplet of RNA bases that codes for each amino acid? Okay. So what name is given to that triplet?
The name of the codon.
So we've now got to look for CCG. So we go back here and we see CCG is? There's CCG.
GGG.
And it is
Glycine.
There we go. Okay, then it says describe how the composition of the protein molecule changes if the base sequence at X is UGU instead of UCA. Now, the minute we change that base sequence, all right, it's going to change the protein. How? Because we have something in the whole process called a mutation. And if something like this happens, it's going to be a mutation and it's going to result in a completely different protein. It would be like instead of adding, if we're making French toast, seeing we're talking about food, and we go and we make French toast, and we don't use eggs.
What kind of French toast is that now?
Exactly. So we will change, we're going to change the breakfast that we're having completely because we don't use eggs.
So now we toast.
Exactly. So that's what happens here, is when we do something like this and that sequence is altered, it changes the entire protein structure. Does that make sense, Sweet Pea?
Yes.
Have you had any other questions?
Yeah, but it's about the Mendel and Lamarck evidence of evolution.
About Lamarck. I love Lamarck. What did Lamarck do? What did he do? What did he do? Tell us what he did.
Let's get a mindset to teach us. We can take a break now.
Come on. What's Lamarck's problem?
At school they gave us like those evidences, the 4 evidences of evolution.
Huh?
Then I don't seem to understand them because like they just gave us them, then they just left like that.
Okay, let me tell you this. Lamarck, remember all these guys lived such a long time ago. They lived a very long time ago.
No Facebook,
There was
no Twitter.
There was no cell phones.
No Google.
Do you know that I can even remember when there was no cell phones?
So can I.
And I sit in my car and I think, how did I ever survive without a cell phone?
You used a ticky box.
Yes.
Do you remember ticky
When I was
box?
at boarding school and I wanted to phone home, you had to get 5-cent pieces and 10, and believe it, you could make a phone call. So it shows you how old I am. You'd have your ticky box, you'd have your coins, and you would go phone and you would put them in. Okay. But anyway, getting back to Lamarck. Lamarck decided that structures changed to suit what we needed. So it was his whole process is the acquiring of characteristics that were necessary. So his example was a giraffe. So if a giraffe had to eat the leaves up here and it stretched its neck, lo and behold, the giraffe would give birth to babies that had stretched necks.
Yeah.
Now, it can't work. Those acquired characteristics cannot work. It's like...
Is it kind of like, humans growing longer arms because we're carrying heavier packets when we go shopping?
No.
Not like that kind of
No,
thing.
it doesn't happen. It's rubbish. Okay, your arms do not grow longer, I promise you. I do enough shopping with my girls. But if, for example, I decided I hate my nose. I hate this nose. So I go
On the nose again.
I go to a plastic
Genetics.
surgeon and I say, this is my father's nose. Oh, goodness gracious me. And my
I don't
dad's.
say the mindset is like your nose. So.
Do they? It's huge.
They
But
love
anyway,
it.
okay, so I've got this snosh, and I go to a plastic surgeon and say, listen, I'd like you to please do rhino surgery and give me one of those little beautiful ski
Button
ramps,
nose. Button
yeah,
nose.
those pretty little dainty noses, okay? Does that mean my children are going to have a beautiful dainty little nose when I give birth to them?
If only.
No. My girls will stand the chance of having this big thing on their faces just like mine. Why? Because we are genetically related. As it is, shame. Or not shame, thank heavens, they got their dad's genes that interfered there, and they got his family's side female noses.
So they missed the nose.
It's a very cute little,
Yeah.
they both got cute
Sweet.
little
Yeah.
noses. They don't have mommy's nose. But at the end of the day, people, that is what acquired characteristics is. You can't, the logic behind it is ridiculous. You can't stretch a neck and then, or like a crocodile. Oh, the crocodile's snout stretched. I mean, hello. And they laughed him out of the ballpark. Nobody took him seriously, apart from the fact that he was, again, one other theorist. And so that's the way not to do it. What he did, though, come up with is use and disuse, or the theory of use and disuse, which is, for example, a mole rat or a mole is down in the ground, and eventually, because they haven't used their eyes become blind.
Yeah.
Okay, our appendix. So we call it a vestigial organ. It becomes something that was used at some time or some stage, but because we don't use it, it eventually gets smaller and smaller. And they've also found on whales that they have vestigial hips, so they could have had legs at some stage. But the bones are sort of like so minuscule and disintegrated and useless that, because it's in this big body, I suppose.
Yeah.
But it's there, and it became a vestigial organ. All right. The same with our appendixes.
Yeah.
They are useless. They're a useless flap of skin.
Yeah.
So when you want to call people anything, if you feel the need to,
Call them a
don't
colon.
call them any of those other words you were going to use. Say it's an appendix. They are just, in fact, make it even better and say they're a septic appendix.
You're a septic appendix.
You're a septic appendix. You see how good that sounds. Okay, so
they'll be like, ooh, what is that?
People, our appendixes are now vestigial organs. We don't use them. They're just this piece of flap of skin. And eventually, we're going to find that in a couple of centuries' time, people won't even have them. And apparently our baby toes are also going. So that part of what...
I have the tiniest baby toe ever.
Do you?
I'll show you after the
so
show.
you're very evolved. The
Very.
same with wisdom teeth. Some people only have top ones or bottom ones or not
Yeah.
both sets. All these things are towards, and that sort of backed up the theory that Lamarck had of use and disuse. But his acquired characteristics was drivel. Okay. And then if we look at Darwin, Sham, the poor man, was so misunderstood. We're going to take a break. We're going to go for an ad break.
Yeah, and a
then
sip
we're
of
gonna-
water.
And a sip of water. I'm dying in here.
Water.
Okay, but we're going to have a sip of water.
Yeah.
We're going to get back and we're going to tell you all about Sham, poor Darwin.
Yes.
Misunderstood.
Poor
Very misunderstood
Darwin,
boy.
shame.
Yeah, very misunderstood.
After the break, we'll catch you then.
See you now.